So we are dealing with a very interesting problem of JEE Advanced 2025 paper 2, and this is based on Carnot Engine, and along with this the concept of a heat pump is also discussed. The problem is stating the efficiency of a Carnot engine operating with a hot reservoir kept at a temperature of 1000 Kelvin is 0.4. It extracts 150 joule of heat per cycle from the hot reservoir. The work extracted from this engine is being fully used to run a heat pump which has a coefficient of performance 10. The hot reservoir of the heat pump is at a temperature of 300 Kelvin. Then which of the following statements is or are correct? So let's get started by first of all understanding the entire situation diagrammatically. So we can understand it diagrammatically like this. So this is the temperature of the hot reservoir 1000 Kelvin, and from here a heat Q1 is entering into the system. This is the Carnot cycle over here which we have on the left side. So some work done will be extracted from this system and it will dump the rest of the heat Q2 to this system which is at a temperature T2. Now over here we are mentioned that the efficiency of this cycle is 0.4 and the value of Q1 is equal to 150 joule. So let us perform the first set of calculation. So we can say that eta Carnot is given to us as 0.4 and this is equal to 1 minus T2 by T1, also equal to 1 minus Q2 by Q1. So over here we will be using it twice. So for the calculation of temperature T2, we obtain T2 as 600 Kelvin temperature over here, T2 by 1000. So 1 minus 0.6 is 0.6 into 1000. That is, we obtain T2 as 600 Kelvin temperature. So we can write here straight away that this is a 600 Kelvin temperature, which we earlier marked as T2. So this is the value 600 Kelvin that we have. 150 joule of energy is entering into the system from here. And now we are solving for Q2. So if we use the formulation 1 minus Q2 by Q1, so 1 minus Q2 by 150, so again we get 0.6 is equal to Q2 by Q1. So from here we get Q2 is equal to 0.6 times 150. This is equal to 90 joule. So over here we can say that Q2 is equal to 90 joule. So the difference of this energy is the work done. So this is the heat energy which flows into the Carnot cycle. This is the heat which the Carnot cycle is dumping into the surrounding at 600 Kelvin temperature. And a work done is the difference between them. So work done over here, which is the difference between them, 150 minus 90 is 60 joule is obtained. Now the question is stating the work extracted from this engine is being fully used to run a heat pump which has a coefficient of performance 10. So a heat pump is going to extract heat energy from the cold reservoir, will mix it with work done and then dump it to the hot reservoir which is mentioned at 300 Kelvin temperature having a coefficient of performance of 10. So this is the useful part, which we say useful refrigeration, and work done is there. So coefficient of performance, so we write coefficient of performance which is 10 is equal to, so this part we have calculated as 60 joule, and if I mention this as Q3, so 60 and Q3 will combine together to make 60 plus Q3, which will be eventually dumped to the heat reservoir. So we can say coefficient of performance is equal to 60 plus Q3 divided by 60, which is the work done. So coefficient of performance which we obtain over here is Q3, which is the heat energy removed successfully from this cold reservoir. So Q3 is equal to 600 minus 60, that is 540 joule. And now we solve for the last part, that is the temperature of the cold reservoir. So if I mention the temperature as T3, so we can say over here that T3 by Q3 is equal to temperature, which is 300 by, so this is 540 plus 60, that is 600. So from here, if we solve for T3, we get T3 as half times of 540, which is equal to 270 Kelvin. So over here, let us go to the options to check how many are correct or what we have obtained. So over here we can say work extracted from the Carnot engine is 60 joule, so it is correct. Temperature of the cold reservoir of the Carnot cycle is 600 Kelvin, this is also correct. The temperature of the cold reservoir of the heat pump is 240 Kelvin, so we have obtained this at the last, this is also correct. And heat supplied to the hot reservoir of the heat pump in one cycle is 540 joule. So heat supplied to the hot reservoir of the heat pump in one cycle is 540 plus 60, that is 600 joule. So heat extracted from the cold reservoir is 540 joule, so this part is incorrect. So for this particular problem, we are going with alternative A, B and C. The fourth alternative is not matching. The rest of the alternatives are correct, A, B and C, for this particular problem.